Good evening, everyone. Thank you for being here. Today, we are going to talk about a problem many of us face daily: digital clutter and the inefficiency it creates. We'll be presenting our solution, a mobile application called My Daily Hub, which we designed to be centralized command center for personal productivity. Yeah. Think about your daily workflow. You might have a to do list in one app, important meeting notes in another, a quick voice reminder you recorded on your phone's default app, and conversations about a project happening in a separate messenger. This is what we call digital fragmentation. Every time you switch between these apps, you pay a small mental tax. Information get siloed, ideas get lost, and you end up doing manual work to connect the dots. This this joint approach ultimately reduces our productivity and adds unnecessary stress to our day. To solve this, we built My Daily Hub. Our vision was to create a single, intuitive, and intelligent platform to manage the core aspect of daily life. This app is built on three pillars. First, organize. It provides a unified place for both structured tasks and free form notes. And second one is capture. It allows you to instantly save ideas using not just text, but also your voice or even by scanning text from an image. And third, connect. It includes a direct messaging features, allowing communication to happen in the same place where work gets done. All of this is powered by cloud, ensuring your data is synced and accessible whenever you need it. Right? For our project, we focused on building a fully functional application with a rich set of features, right? We have a secure user authentication for user accounts. We implemented advanced task and node management that allowing users to not just create items but also attach files and record voice memos to them. And a key highlight is our AI powered capture. We integrated two major Google Cloud AI services directly into the app. Speech to text for transcripting voice memos on the fly, and optical character recognitions to uh, scan and digitize text from images. Also, we build a complete real-time direct chat system where users can find each other and communicate live, complete with unread message indicators. And finally, we offer user setting, including a popular light and dark mode theme toggle. Yeah. Let's look at the technology that make this possible. Our architecture is modern and scalable. This front end is a native Android application built with Flutter and Dart in Android Studio. We chose Flutter for its fast development cycle and the ability to create beautiful, high performance user interfaces from a single code base. For our backend, we relied entirely on Firebase as our backend as a service. This gave us a powerful suite of tools without the need to manage our own servers. And to add intelligent capabilities, we made direct authenticated API calls from the client to cloud, Google Cloud's AI APIs. Diving into deeper into our background, we use two core Firebase services. First, Firebase authentication. This service handles our entire user identity flow, from registration to logins and session management. It is the security backbone of our app, providing a unique user ID or UID for every user, which is critical for securing their data. And the second one is Cloud Firestore. This is our primary NoSQL database. It's where we store all application data in a structured way, from user profiles to individual tasks and nodes, to the metadata for chats and the chat messages themselves. Firestone's greatest strength for us is its real-time capability, which is what powers our live chat feature without any extra work. For any non-text data, we use Firebase storage. When a user records a voice memo, the .wav audio file is uploaded here. When they attach an image or a PDF to a task, that file is also stored in a Firebase storage. Crucially, we designed a secure file structure organizing all uploads into user-specific folders based on their unique ID from Firebase authentication. The security rules we brought for the storage ensure that a user can only access their files, providing data privacy. And Firestore then simply store a reference, the download URL to these files, keeping our database lean and efficient. Yeah, to make our app truly smart, we integrated two powerful Google Cloud AI services directly from our Flutter client. First, the Cloud Speech to Text API. After a voice memo is recorded and uploaded, our app sends the audio data directly to this API. It returns an accurate text transcription, which we then save alongside the audio in Firestore. This makes voice notes searchable and easy to read. Second, we used Cloud Vision API for its OCR capabilities. User can picture from a picture of a document, a whiteboard, or even a book page. This app sends this image to Vision API, which extract the text and allows the users to instantly pull it into a new note or a task description. One of the most complex and rewarding features we built is the direct messaging system. This is the powerful demonstration of Cloud Firestore's real-time capabilities. Here how it is work. To start a chat, a user can search for another registered user by their email. This is possible because we store a user profile in a queryable user collection in Firestore. When a message is sent, it is not going through a traditional server. Instead, it's written as a new document into chat IDs messages subcollection in Firestore. This magic happen on the recipient's end. Our app's chat screen uses a Firestore stream listener, especially the snapshot method. This creates a live connection to a database. The moment a new message document is added to that subcollection, Firestore pushes the update to our app instantly. The UI rebuilds and the new message appear without any need of pull to refresh or a separate push notification system for in-app updates. We even implemented a client-side unread message indicator by storing and comparing timestamps in main chat document, giving users a clear visual cue for a new activity. Of course, building a feature-rich app like this came with its challenges. Our first major hurdle was with five-star security rules. It's easy to make them too permissive or too restrictive. We had a specific permission denied error when trying to create a new chat. The solution was to design a conical chat ID based on the user's UIDs and write a rule that could validate a user's permission to check for that documents even before it's exceeded. And our second challenge was the cloud API permissions. Our first attempt to use the speech to text failed because the STT services, acting as an anonymous caller, couldn't access our private audio files in Firebase storage. We solved this by pivoting our implementation. Instead of asking the API to fetch the file, we send the audio data directly as a byte stream in the API request. This required us to be very precise about the audio encoding configurations, especially recording in wave format and declaring it as linear 16 in our API call, which ultimately resolved the permission is issue. Yeah, this project was an incredible learning experience. We gained deep practical experience integrating a suite of cloud services, Firebase out, Firestore storage, and clouds, Google's Vision and speech to text APIs. We mastered a real-time data flow for our chat features and learned intricacies of writing robust multi-layered security rules. Looking ahead, our top priority wouldn't be implementing Firebase cloud functions to enable server-side scheduled push notification for task reminders. Following that, we would like to advance filtering and sorting full Google current integration and expand our chat into collaborative group workspaces. In conclusion, my daily hub successfully demonstrated how a modern mobile app can solve a problem of digital fragmentation by integrating key productivity tools. We have shown that by using Flutter and suite of powerful cloud services, it's possible to build a feature-rich, intelligent, and user-centric applications. Thank you for your time. Now, Rashad will give you the live demonstration of my daily hub.
Yeah, thank you, Nuha. You have given a perfect introduction about our app, how we have done that, how what are the features we have used, and what are the problems we have faced, and what are the challenges we have gone through on our application development. Before going into the demo, I want to briefly walk you through our project architecture. As you can see here, we have structured our Flutter project for our scalability. We have a clear separation for our models and our cloud services. Like, yeah, you can see here, these are the modules, and in these services we have authentication service and the vision for the authentication, Firestore, and the chat services. And also here is Azure is here, but I have tried that one, but it didn't work, so that's why I have used the Google speech services and these screens to handle the UI. This is a clean structure. This is a clean structure. and this was essential for managing the complexity of the features we are about to see. And to show you how this architecture is implemented in the practice, let's take a look at the live backend for my daily hub in the Firebase console. And you can see here, this is the Firebase console overview, and this is the authentication part, and this is the Cloud Firestore, and this is the cloud storage, Firebase storage database. And see, you can see here, I have registered two users earlier to show this one, and these are the unique user IDs. And you can see here, they each of them have the checked-in users, so that this is a Cloudflare. Cloudflare Store is our brain of a application. It is a NoSQL database where all our structured data are stored. As you can see, we have designed a user-centric data model. We have top-level users collection. In here, you can in each user they have own document ID. As we have seen here, each users have the own document ID. Now I you can see here, if I click the users collection, each user has separate documents for each of them with the unique ID. This is for the user one, and this is for the user two, previously created accounts. And you can see here within that we have also some collections like FCM tokens and nodes and tasks. FCM token is used for the cloud messaging, but it's under development. And the and we if we gone through the notes part, you can see here there are three documents inside that. I will show how this is happening when I created the task and the notes while using my app. And these are the tasks. So you can see here it has the 7 tasks, and if I click that single task, you can see what are the attachment it has, its description and the date and the ID and the title and so on. So if there is a let's go here. If you can see here, if you can see, I have before going to the demo, I have uploaded the audio here. It will be stored in the file storage. So you can see here the audio duration is 7 seconds and the transcribed text also here. So if I go show you the Firebase storage, we can go to the click and go to the users one to the collection, and if we have gone inside, we can see here notes and the task. Then if I click the task, it will redirect to the specific task. Like, yeah, we have 7 tasks. In here we have 4 because we have only added attachment for 4 tasks. In the voice notes, you can see here there is a voice note for the specific task. So also we can see here the same as here. Now you have gone through the Firebase pipeline, and these are the services that what I have used from the Google Cloud. And you can see here I have used the Cloud Vision API and the Cloud Speech. Those are the main API I have used in this, and the Firestore, the Run API, and those are in the Firebase part. And in here, mainly I have used the speech to text and the Cloud Vision API. You can see here, these are the usages that I have done so far. Now we will go through the mobile application demonstration part, and we can, first of all, we can start with the registration and the login part. Here you can see the app is getting started. Here, first of all, we have to register the user. So we have to click the sign up screen, and we have to add the specific credentials for this as well. First of all, we need to give the credentials for the user before we are registered. If we didn't do and If we let that empty and if we click to register, I have validated each and every field how it need to be look like. And email also verified with the regex, and the password also verified with it has to have those and the, just like symbols and the numbers and the capitals and symbols, just like that. First of all, I will add a use like user3, and his email is user3 at test.com, and I will add the password as the same as that, and the I will change only the capital one. In here you can see these things is just for the testing part, and I have to click the agree for the terms and services. And if I click register, it will create the account in the Firebase, and you can see here the registration is successful. Please log in. And if we move directly to the Firebase part, and now you can see here, so I need to refresh this one. Then you can see here whether if it is, sorry, here you can see user 3 has been registered. Now, if I refresh here, it that also will be appear here as a document. So, you can see here user 3 has been registered, but we didn't create any collection for the nodes and the task. We didn't create any nodes and tasks for this one. And XCM token is inbuilt in each and every function. Now, if we first of all we need to log in here. I will give the same credentials for here. So you can see here, I have created the forgot password screen as well. Then it will send the link to the email, and we can change the password from there. Now it has been redirected automatically to the task lists. This is a auth service.dart file, which gives in our auth services file, it will register with email and password method. It has the two key things. First, it uses the Firebase authentications to securely create the user. Second, and crucial for our chat feature, it creates the corresponding user profile documents in Cloud Firestore under the users collection. As you can see here, yeah, these are the parts they are mentioning. So, uh, just like first of all, where I will explain. Yeah, if you can see here, it is Firebase Auth to create user email and password with the name of the users collection. And you can see here 54. You can see here it is creating a collection like users in the database, and it is the collection we can see here. After the moving to the task list screen, in the main.dart, we have added a function like in here we can see if it is authenticating, it will uses the splash screen just like initializing app, and it will load. And if the user email is not valid, or else if it has any problem, it will redirect to the login screen, or else it will be redirected to the task list screen. It will be handled by the auth wrapper widget in the main in here. Now, first of all, we need to add a task, right? In here, where if I click this plus button, the floating action button, we can see there is we can see here task title and the description with the dates and the voice memo. and the attachments. And here I will add a task like study, and here by today evening. Okay, now I will set the time as it was 29, right? And okay, I will set the time as like 7 o'clock. 7 o'clock. Okay, now it will create the task. Now I can add an image here as an attachment or else PDF as an attachment. For this, I will add an image. It is quick loading. You can see here, I will add this one. So it has been here. Now, if I click add voice memo, it will not record the audio because I was recording simultaneously in the Zoom as well. So it will just upload the empty file just like it has been empty recorded file. So if I click on, then it will run and upload it to the 5 days. Yeah, you can see here it has been created, but you can't see any output for this one here. So I will use my mobile phone to uh, I will use my mobile phone and be record at the same time with the Zoom one, and we can see I will attach it to here. Then you can see how it is working, right? So now I will add a now I will add a task in here, just like I was using the user 3 to add a task. After completing the login in my mobile, now I have to record that one in the mobile as well. Now I will add the task. Then I will add the title as dentist appointment. Now I didn't add any descriptions. I will set by tomorrow. Tomorrow it means 30 at 12 o'clock. Yeah. Now I am recording a audio like schedule dentist appointment on tomorrow. So right now I will save that one. I'm not going to add any images here. So it will save here and it will upload it there. Yeah. First of all, in here what is happening is it will upload the file to the Firebase storage, and the audio data was sent directly to the Google Cloud speech API for the transcription. So now I will show this one here, and if I refresh this one, you can see here dentist appointment and schedule dentist appointment on tomorrow. Yes, we can see here. If we play this one, it will work here. The sound is little bit lower. Now, what is happening here? Now I have to go for the fstate.dart to, first of all, we need to understand what's happening with this one. This is, in this, we have the main orchestration in our app state. So for we have to go for the server application. Application the line 418 and 469. I have get those things earlier because we need to explain these things. In here, what is happening is we use a future.wait to run the upload to Firebase storage and transcription call to our Google speech services concurrently for efficiently. This is for the notes part, and we have added the same part, same thing for the task part as well in the line 418 here, from here. Yeah. We have added the task, and the below one is the voice note part. And you can see here, if the text is not the voice is not transcribed, it will fail like this. So if the voice is silent, and it will be given like this one. Now you can see here, we can edit these things and add in one. Oh, we can add files from here. We can do, it's been loading. You can see here, we can add files from here. And if we click, and we can add some more files as well to here. And it will upload to the Firebase. And you can see here, if I refresh this one, it's already speak over. And you can see here, we have two tasks, and this is the task what I have. I hope this is the task what I have created right now. And you can see here, no, this is the task what previously created. Now you can see here, yeah, schedule event is appointment tomorrow, and this is the Firebase storage URL for the, this is for the image, and this is for the audio file. So now we can go here, and also we have added the images, right? We can view this from here in the image view screen. Yeah, yeah. Also, we can add PDFs for that as well. And if we click this one, it will be like here. Also, we can delete from here. Yeah. And now editing and adding the task part has been over. Now we will move to the and then edit the note part. Okay. Uh, in here also we can add by clicking the plus icon. So first of all, I need to add a basic title like DSA, and I can also add any contents here. But with also I have added the Cloud Vision API for this one, which will detect the document text, and it will convert it to here into text. Just like if I add an image, it will read the files, just like it will work like the Google Lens one. And it will read from the images, and it will add the content to the here. It's quick loading. Yeah. Now you can see here, I will add this as a content one. Yeah, it will work, and it will add the content to here. It will take a little bit of time. Until that, I can show you the vision service here. And here you can see the request body. This is the main part where document text detection feature has been sent with the base 64 images, and it will directly send to the content part of the this one. And those things are mentioned in the screens in there, and the encoded image data will be in here. And you can see here what are the things they have added, like, yeah, it's mostly everything in there with the correct alignment with those things. Now if I click the add, it is the same like same like the task part, and it has the only difference is the content part with the optical character recognition using Google Cloud Vision API. And also, we can directly add, as you have seen, we can directly add that from at the images from the by capturing in that one. And just like that, just like task nodes full support the create, read, and update delete operations with all securely stored in the Firestore database. Firestore and under the user's profile. And you can see here, it has been here. Yeah. And I didn't add the voice note because we have seriously gone through that one, previously gone through that one. Yeah. If I click this one, it will be downloaded and open in the browser, the PDF for this is for the PDF. Now we have to wait for a bit, but I will go for the other demonstration part. Yeah. So now you can see here we have here you can see the note has been added. Now only I have added a one note, right? Then it will be here. And with this one, it has the content here and the date and the voice note is null. And the title likewise, it will be here. And then now we will go to the one of our main it is a normal feature. Just like we can search from here. As the if we address the DSA, it will I will record that video in the mobile and I will attach here. Then you can see just like now I will search like letter. You can see it the color is being a little bit lower. And if there is something just like I have, if I search like DSA, there is nothing. If I search like MCQ, then it is here MCQ, and you can go like that one. So the this part has been completed, and now we will go to the chat part. Yeah, in here users can chat directly with another user by searching the username. Just like I will search as user. Yes, we have to give the user who have registered previously with this one, and here we can see there is no user, and I will I'd like user to at test.com. If I click here, it will redirect to the chat screen, and it's like this. This is how this is working. This search query our users collection in Firestore using where close the and you can see here and this is the Firebase. This is the cloud Firestore, right? And we can see here in the tools. Uh, yeah. When I check when I click the chat service one, checks if a chat document for these two users already exists. Since it doesn't, it creating a new one. Just like here we have created one, right? In the now I am in the five-star rule. This is where our most complex security rules comes into play. This allows us to get rule from chat to chat ID, as you can see here, gets to chat ID, and this allows the app to check for the existence by validating the current user's ID is a part of the document ID itself, which works even if the document doesn't exist yet. This was key to solving our permission derived errors. I have faced so many issues while creating this permission for the chatting part. First of all, and you can see here, this is the main part in while creating the chat one. Now we can see here, I will go to the app and I will add the message like, can you review the presentation tomorrow? Right? By tomorrow for this user. Okay. Now if I send that one, it will be received by the other user in the other end. So I will record it from my mobile, and you can see here user has been comes here, and if he sends another thing, yeah, in the other user's end, the message will be instantly appears because of the Firebase real-time streams. The document is created in sub collection and the parent chat document is updated with the last message details. And you can see here in the Firebase data, and you can see here the chats. There are some chat IDs for the specific users just like this. And you can see here user one and user two are previously interacted with this one, and the this is, I hope this is for the user 2 and user 3, right? Yeah. This is for the user 2 and user 3. We can also see the messages from here. Also, in here, I will share like, okay, then it will be instantly updated here. Just like that. If I long press this one over the message, I can edit to the task. So you can see here, the task has been created from this, and I have to set the date by tomorrow. Okay, tomorrow. Okay. If I click that one, the task will be saved, and you can see here, task has been created. Just like this, our chat system is working. And now we will move to the settings. The most probably those are the things we have to do with these things. And the Firebase streams help us to Firebase streams and the indexing from the Firestore help us to the chatting part. Now I will move to the settings screen of our app. You can see here I can change into dark mode and the light mode. Also, we can enable the reminders and disable the reminders. And here we can see the logged in user details and theme preferences just like dark mode and the light mode. Also, the logout button. If I press the logout button, it will be logout securely from the app and clears all the local style what we have been used here. The entire flow of this managed by our central app state, listening to our Firebase authentication stream. Most probably the app is our main brain is the based on the our app state. It will provide every one of the thing, each one of the thing what we have to do from here. It is the one who controls each and everything, just like adding and keeping the files, adding the files, and while uploading what we have to do, what if it didn't work, and every one of the thing is done by the appstate.dart part. And that concludes our demonstration. We have shown a fully integrated system for managing tasks, nodes, and chat powered by a powered by suite of Firebase and Google Cloud Services, all running in a single Flutter application. Thank you for listening to this. Thank you all for listening.